IL-22 is not your typical pro or anti-inflammatory molecule. It occupies a rare and essential space in the immune system, acting more like a molecular guardian than a blunt weapon. Produced primarily by a specialized subset of immune cells, including type 3 innate lymphoid cells, ILC3S, Th17 cells, and certain DT cells, IL-22 is best understood as a cytokine that doesn't directly kill invaders but instead fortifies the battlefield. Its job is to strengthen the physical and biochemical infrastructure of the intestinal lining, creating a resilient interface between the chaotic microbial world of the gut and the immune-sensitive tissues underneath. In essence, IL-22 builds the wall, maintains it, and keeps it sealed tight against microbial trespassers and dietary irritants. At the molecular level, IL-22 exerts its effects through binding to a heterodimeric receptor composed of IL-22R1 and IL-10R2, found almost exclusively on non-hematopoietic cells like epithelial cells and hepatocytes, never on immune cells themselves. This limited receptor expression is part of its design. IL-22 is meant to act locally on barrier tissues, not to amplify systemic immune activity. Once IL-22 binds its receptor on gut epithelial cells, it activates the JAK/STAT signaling cascade, particularly STAT3, which drives a suite of protective gene expressions. These include genes for tight junction proteins like claudins and occludins, which seal gaps between epithelial cells and prevent unwanted molecules from seeping through. IL-22 also stimulates the production of mucins, the backbone of the mucus layer that physically separates bacteria from host tissues. But IL-22 doesn't stop at merely plugging the holes. It initiates regenerative programs, promoting epithelial cell proliferation and wound healing. In conditions of damage, whether from infection, oxidative stress, or dietary inflammation, IL-22 accelerates the replacement of compromised cells. This makes it an essential player in both defense and recovery. It also induces the expression of antimicrobial peptides such as Reg3 and SS defensins, which directly limit bacterial overgrowth at the epithelial surface. These peptides don't just kill indiscriminately. They target pathogenic and opportunistic microbes, helping maintain a healthy microbial balance without inciting collateral damage to the beneficial species. Importantly, IL-22 also acts as a buffer against immune overreaction. By keeping microbes and food antigens from breaching the gut barrier, it reduces the chance that deeper immune tissues will be exposed to inflammatory triggers. In this sense, IL-22 is an inflammation preventer, not just a damage controller. In mouse models, IL-22 deficiency results in greater susceptibility to colitis, systemic infections, and even food antigen sensitization, clear evidence that without this cytokine, the gut becomes a porous, reactive, and unstable organ. This protective capacity becomes even more crucial under dietary stress. High-fat diets, for instance, have been shown to suppress IL-22 production via lipid accumulation in ILC3S, effectively muting one of the gut's primary defense mechanisms. With less IL-22, tight junctions become compromised, mucus layers thin, and epithelial repair slows. This leaves the gut more vulnerable to leaky barrier syndrome and immune dysregulation. Compromised IL-22 activity is a key reason why a seemingly benign diet can open the door to microbial imbalance, low-grade inflammation, and ultimately, systemic metabolic and autoimmune diseases. Even more intriguing is IL-22's emerging role in tolerance, the process by which the immune system learns to not respond to harmless dietary proteins. By strengthening the epithelial layer and preventing unnecessary antigen exposure, IL-22 reduces the risk of food sensitivities and allergies. Its ability to shield the immune system from dietary noise may help explain why early life disruptions in IL-22 signaling correlate with higher risk of allergic and inflammatory disorders later on. Ultimately, IL-22 is a biochemical shield, not in the sense of violence or attack, but in its quiet, architectural work, patching holes, sealing seams, rebuilding walls, and maintaining peace in one of the most immunologically charged environments in the body. Its decline, whether due to poor diet, chronic stress, microbiome disruption, or genetic vulnerability, marks the beginning of a slippery slope toward gut dysfunction and inflammation. And its restoration? That's the beginning of healing.